This problem is O1 matrix. Now, the problem says that we are given a binary matrix and we have to return the distance of the nearest zero for each cell. Now, the cleanest approach is a multi-source BFS, which means we're going to start from all the zeros simultaneously and expand outward. So each one gets labeled with its distance the first time it's reached. What is a multi-source BFS? It's just a regular breadth first search with one twist, which is instead of starting from a single node, you initialize a queue with several nodes, all are distance 0, and then you expand outward as normal. Now, why are we using a multi-source BFS? It's because running a BFS from every one individually would be O of m times n whole square in the worst case. So by seeding the queue with all zeros at once, each cell is visited exactly once, and BFS level by level expansion guarantees that the first time a cell is reached, it's via its shortest path, and this way the time complexity will be O of m times n and the space complexity will be the same. So I'm going to explain the code step by step over here. So over here, we are going to start with setting up. So which means we grab the matrix dimensions and we create a distance matrix of the same size filled with -1. So this matrix plays two roles at once. So it will hold our final answer, which is the distance to nearest zero for each cell. And it also acts as a visited marker. So each cell at -1 has not been reached yet. So keep that in mind because we're going to use it. Now we also create a deck, which is a double-ended queue, so because it gives us O of 1 pop left. Now over here, we are seeding the queue with all zeros. So this is the multi-source part. So every cell containing a zero is a source, and its distance to the nearest zero is also 0. So we record that and we put it in the queue. Now over here, while our queue is non-empty, we are going to process the cells in the distance order. So we pull the cells off the front of the queue. Now because everything at distance 0 was on-queued first, then everything at distance 1 gets on-queued behind it, then distance 2 and so on. The queue naturally processes cells in increasing order of distance. Now over here we have directions, so it's up, down, right, left. Then we are going through the directions, so we are looking at all the 4 neighbors and we are adding them to our current position. So that is giving us the coordinates R, NR and NC. And then we are filtering the neighbors. So we are doing 2 checks. So firstly, the neighbor must be inside the grid, so we don't go out of bounds. And then it must be unvisited. And that's what I said when I said keep in mind that everything initially is initialized to 1. So it must be unvisited. So this unvisited check means if it's -1, it prevents infinite loops, and that's what it guarantees correctness. And now we are gonna do the main bit, which is record the distance and then on queue, which means the neighbor is 1 step further from a 0 than the current cell. So its distance is distance of RC, which is our existing point where we are at, +1. So we mark it immediately upon on queuing, not when we are popping it. So this is important because otherwise the same cell could be added to the queue multiple times by different neighbors before being processed. And then at the end we just return our distance. So when the queue empties, every reachable cell has been labeled, and then our distance is the answer.